Hi, so it's 23rd May, and today I progressed more upon that rack project of mine. So I was working with this LLM, and I did a lot of other changes as well. To the I tried Gemma, so that didn't quite work, but I modified some things as well here. Let me get to the library. So if I open the editor here, so this is the main.py now. Everything is in the main file is the basic algorithm is still the same, but the changes that I made are in here. Let me just get to it. Yeah, so I was already handling the PDF functions. The PDF functions work quite well, but today I have added the Excel compatibility. So for Excel, what I have done is I have taken all these files, which are CSV files and XLS files and XLSX files and ODS files, and separated them for different file types, and got the path object for each of them, and populated them with the relevant the relevant sort of the JSON for each file, and this is what I got from that, and it worked quite well. And it was separated into CSV and XLSX by the if else, and I installed this OpenPyXL library for handling each of these files, and use data frame to extract things from the data and do the queries like this if and these all these statements, which are usually done in SQL. I'm doing it in pandas in order to extract these things, and after that I save these files and return the return value, whatever that is. And also the another change that I did there is that also made an option to allow external API to connect instead of just Olama. So what I did was I got to the Olama rack query function, and made provision for it to also include Gemini in this. So what it does, it if it detects that Gemini is in model name, it does the Gemini query, and in Gemini query I have this clean function in which I pass the Pydantic class to the Gemini response schema and response structure, and returns the relevant sort of the JSON object, which has to be returned from the LLM as the Gemini API key I've already given here. So this is what I have already done in the document control pipeline part of the deal. And also what I did was I more studied about the fine tuning stuff. For that I wanted to train the OpenAI model, but it required OpenAI key API key. So we don't have the API key right now, and my API key has all the tokens spent off, and so I didn't have that. So what I decided to do was, let's do it on Conda itself, on some some old function or something. So for that I have gone through a lot of the other examples of LoRa encoding, and for that, to get the adapter to adapt the basic LLM to the changes so that it does perform well. So as an example, I tried to take the one of the styles that I wanted to have the LLM to have in order when it speaks. I wanted to change its tone and style, uh, you know totally. So what I did was, let me show you the leads here. So this is my directory here. What I'm doing here is that going to the let me show you yeah. So this is the total document. In this I have used the electrons, and the entire lecture is in a certain tone and style. It says, alright, listen up, you want to know about electrons? Oh boy, they are the interesting. So it's more like in North American sort of the accent, and or it is a mix of Brooklyn accent and sort of Boston accent, and these are basically the words are like this, but what I'm planning to do is I'm taking all these text things, the certain tone and the tonality and the repeating words and everything, which was usually done by Richard Feynman. He was a guy, professor and scientist, renowned scientist. So in his style, I wanted to change the LLM's output. So what I did was I copied an entire corpus of his lectures and concatenated them together. Like, this is electrodynamics, magnetohydrodynamics, and we also have these equations in the middle. So I think that's good for the LLM. And then there is quantum mechanics. So I have a lot of data, and what I think will happen is that it will try to predict what word will come next, and for each word it will try to predict the next word, and it will do feedback loop such that on the loss function of it, and it will do for each word here. So what will happen is the weights will get updated. Now the only difference in LoRa is that only a few weights will get updated instead of the entire weights. So because it is a PEFT model, in PEFT methods you don't have the entire weight trained on the loss function according to it. So this is it about it. What I did was I trained the model on this. Let me show you been a bit of an example. So this is the notebook file, and this is the older code that I had. In this I have concatenated my own code. So this is the imports part of it, and I've installed all these libraries. So that's got to be enough. I think that's all the libraries that I need. And after that I trained it on the trainer, and we have this data set that I made from this particular file that I already had. I'll show you. And after that I logged in into Hugging Face and downloaded a model, got the auto tokenizer for causal LM, and made it the parameter with CPU, because Colab doesn't have GPU apparently right now. And so I know I do understand that this was a bad decision, because this has been running for like 6 hours now, and I think I'm going to close this thing. Now I don't have a GPU enabled laptop right now or any desktop. I think I would be scrapping this project entirely, because this is not running. Maybe do one or two epochs, because I mean even if I do it, it doesn't do it any good, because the weights won't get really updated. The learning rate is too low, and if the learning rate is too high, it will be very very inaccurate and it'll just go off in some other direction. I don't want that to happen, and the entire model will get destabilized. Instead of helping the model, I'll be destroying the model. So this is the LoRa config. So these are all the weight matrices which are being modified after each update. Here we have the Q matrix, K matrix, V matrix, these projection matrix, up projection matrix, down projection matrices. So and there is also the LM head, which is the last module which is there, which does the softmax of these things. So this is we are updating a whole lot of things. That's quite visible. And so after that I'm doing this get PEFT model, and we are giving the training arguments. We're doing AdamW optimization algorithm, and then we have SFT trainer parameters. This is basically the most important parameter out of all these parameters. Is this thing, it's the low rank adaptation rank. So the smaller the rank there is, the smaller the matrix there is going to be of the adaptation. So when we are training the adaptation instead of the entire weight. So for that we need the low rank adaptation to be lowest rank possible, in order to have the fastest updates. But if we do it higher, it will be more thorough. Although it will be slow, but it will be more thorough of an update. It will be more better adapted to the data. So if I do it that, it will be more accurate. But all the more the fit of the LLM on this will be totally, I mean, mostly be dictated by the number of steps it will take. So it will take a weight decay of 0.01 and it will take 500 training steps. So this is a very important number right here. This will dictate that, and yeah, so we'll save it after Hugging Face. I just stick at this for like 6 hours right now, so I think I'm going to lower that number or maybe use another machine or something. So this isn't this isn't getting training today, but I hope to maybe bypass this problem by using some sort of API or free available API or something. uh, After that, maybe DeepSeek has a some sort of a fine-tuning function or something. So let's see what that holds for us. I mean, there are some low parameter models there too, but Colab doesn't provision me any GPU or any neural engine of some sort. So let's see what it gives. So yeah, tomorrow I'm going to chill out for a bit and maybe learn more about low rank adaptation for a while, and maybe inference some of the old models that I fine tuned before, and change these parameters on even smaller models or something. So yeah, cheers.